The following short video clips aim to provide an example of how our clients in other industries use our 3D Experience platform to model, design, test and stress test products in the virtual world to simulate real life.
Safety analyst starts from system architecture done by a system architect. He selects a given failure mode of a system. He identifies possible events that could contribute to this failure. He can define a breakdown of events by determining the combination of events with Boolean gates. The result is a fault tree of a system that includes fault trees of subsystems. From that tree, the safety analyst can make qualitative safety analysis. He identifies critical events called minimal cut sets such as simple failures or dual failures that will drive to the system failure. He makes also quantitative safety analysis by defining for each event of probability of occurrence. The result is a probability of occurrence of a failure mode of the overall system.
Having just seen the probability of failure rate of a part on an aeroplane, next we can see the failure of an engine in a car.
Quality analyst starts from system architecture done by a system architect. He selects a function from a given component. He identifies potential failure modes. He defines potential root causes and their effect. Prevention controls are defined with the system architect to prevent or reduce the likelihood of occurrence of the failure causes or effects. Detection controls are also defined to detect the failure causes or mode in time in order to take corrective actions. The occurrences as well as the detectability are quoted on a scale of 10, from the less to the most critical. The resulting severity is defined by the multiplication of these quotations. For critical failure modes, architecture improvements are proposed to system architects. All FMEA studies can be combined through failure modes and causes. FMEA can be used not only on architecture but also on physical and processes.
The platform is scalable and virtual cities are being modeled in the 3D Experience platform. The following describes Singapore.
Humidity, temperature, and even noise and light intensity are recorded on devices worn by students. This data is fed back to Virtual Singapore to help build a comprehensive 3D model of the city.
So Virtual Singapore wants to be the platform where we could test different ideas, provide services that make people's life much easier and more efficient.
We are modeling and simulating the way wind flow into a town area. When we run the wind flow analysis, we'll be able to see where are the areas that's being blocked, and we can improve the way that we arrange the building types and blocks so that we introduce wind channels so as to enhance thermal comfort. Virtual Singapore allow us to just grab the maps, very detailed forms, and just run the simulations. Virtual Singapore is really a collaborative platform. Other government agencies can also put data, and so with more richer data, it will mean that we are able to plan better. And if we are able to plan better, it means better living standards and lives for our residents.
Use the platform to assign tasks and manage resources around the service. The platform has open APIs, REST APIs, connectors to integrate with any type of system to provide that single source of truth. The graphs and charts are based on real-time data that has been aggregated from multiple sources into the platform. In other industries, suppliers are also on the platform. Imagine visualizing the impact on services due to a change in the supplier or supplier's supplier. Each user can create their own dashboards. There is much more to the 3D Experience platform, and we invite you to take a closer look.